Okay, welcome students and continuation of the module 1. Today we are going to discuss about oil burners. So what do you mean by first of all burners? Where the burner means where the combustion is taking place. The device which produces combustions, okay, also we call it as burners. So what is general principle of oil firing or burner? So the main function of this oil burner are to mix the fuel and air in a proper proportion. It's very important, and to prepare the fuel for the combustion. So this oil burners are classified as like this. One is based on vaporizing oil burners, that are one is atmospheric pressure atomizing burner, rotating cup burner, recirculating burner, wick type burners. And the main second category we call also categorize as atomized fuel burner. So in that mechanical or oil pressure atomizing burner, and rotating cup burners and steam or high pressure air atomizing burner. So these are all the types of burner. So let us discuss one by one the function of oil burners. First one is uh, rotating type of cup burners. So how it is going to be work? The construction of rotary cup oil burner is schematically shown in the figure. It consists of a horizontal rotary cup that runs at a high speed about 3000 rpm. The oil is supplied at a center through the inlet port, and it is sprayed on the inner surface of the rim of the high speed rotary cup. So what happens? The oil is spun off the high speed up cup due to the that centrifugal force as vary with the fine particles into the air stream enter into the cup periphery. What happened? The atomizing is taking place. So atomizing of the oil. Atomizing oil means what? It is divided into number of particles. Atomizing means the oil can get divided into number of particles like this sprinkle. Okay, so air will be going atomizing. Oil fuel is going to be atomized, and the direction of the rotation of the cup and the direction of the flow of the air are opposite, such that the both air and fuel mix thoroughly by swirling action as they leave the burner and burnt easily. Such burners have a wide capacity ranges, as the rate of oil burnt can be easily regulated by controlling the inlet port size at the center of the cup. So this is how the rotating cup burners are going to work. Next one is we'll discuss the further topic for this. Let us discuss next one, oil pressure burner. So this is also called as a mechanical burner. The construction of a typical oil burner, schematically it is shown. So in this burner, what happened? The oil is subjected to high pressure and atomized by passing through the orifice. So this is an orifice. What you are seeing now, that is orifice. Okay, so that is the side view of this orifice. So mainly it is orifice is very taken a very important role in this type of burner. So this oil is supplied under high pressure around 10 to 20 bar. Usually the oil passes through this a swivel chamber and thoroughly get mixed with the primary air, so that we can expect proper mixing of air and fuel. So hence the oil under pressure and just ejected out of the orifice, and it breaks down into the fine particles and forms conical oil mist and easily undergoes combustion. So this is one of the method. Both oil and that is fuel and air are mixed properly, and it is atomized and is passed through the orifice, and it is sprinkles. So it breaks down the fine particles and it forms conical oil mist and easily undergoes the combustion. And this oil flow through a orifice can regulate it with the help of control piston. So here the piston will be is there, control piston will be there here. Here that will be there. So the oil under, when the oil is get under pressure, so it is pushes the oil and it is get pressurized, and here it will be atomizes and it will be sprinkled through the orifice. Okay, this oil flows through orifice can be regulated with the help of control piston, that is plunger, like where it is used in your pen also, like that a plunger, and which closes the tangential spots to the required level. So this is how the oil pressure burner can be work out. Okay. So further we are going to discuss about steam or high pressure air burner. So what is meant by steam or high pressure air burner? Steam or air high pressure burner. So nothing is here. We are expecting more high pressure in this kind of burner. So what is that? In this burner, oil is going to be atomized with the help of high pressure compressed air or steam. The high pressure air or steam enters the nozzle and mixes with the fuel. The air and oil are supplied through the two different channels and are mixed either within the nozzle before leaving it or outside the nozzle after leaving it. So the principle of such burners is schematically is shown. So you can see step by step. Okay, this is oil or steam pressure burner. So these are all steam which is passing over here through the burner. Here that centrally the oil is going to be entering at this at the above side. So here oil is going to be taking place here oil, and here the steam or air is going to be there. When oil is come out and air also it is mixed with the oil, that is the fuel, and then it is sprinkles. Okay, so the various directions are shown in the figure. So depending upon the requirement, and that gives the different size or atomize the mixture or the fuel. Okay, so next one is pulverized burning system. There are two types of pulverized fuel burning system. One is unit system, another one is central system. So here we are going to discuss about unit system. So in this unit system there are mechanisms. In this unit system, each burner and pulverizer constitute a unit, and it consists of a raw coal bunker, a feeder and pulverized mill, a separator and burner. So in operation, the raw coal is supplied to the bunker, so where it is crushed to the required size. Okay, and this crushed coal is then fed into the pulverizing mill. So through this feeder at the required rate, depending upon the combustion requirement, the hot gas are passes through the feeder to dry the coal. The dried coal is pulverized in the mill and it is carried out to the burner. An induced draught fan is used at the pulverize to carry the powdered coal to the burner. A separator is also provided for to separate the grains, means very small sizes of the coal of the size from the powder, and return to the pulverized for the further crushing. Okay, this is a schematic diagram. So what are the advantages of this unit system is it is very simple operation and economical than other kind of system like central system, and combustion is also controlled by directly after pulverized, and maintenance cost is as comparatively it is low, and the fuel supplies to the burner can be controlled easily. And what is the disadvantage means it is variable loads. Main thing is variable loads. The performance of the pulverized mills is poor as the system operates the variable loads, and also it is total capacity of the mills must higher than the central system, and this unit system fuel burning is less flexible. It is not appropriate, but it is less flexible. And whenever any auxiliary space, the burner has to be put off. That is the one of the drawback. And wear and tear of the flat blades, fan blades, and more, since it handles the hot air and cold particles, and strict maintenance of pulverizing mill. It is a must have perfect operation of the systems. Okay, this is about the unit system. Let us discuss about the next central system, or we call it as bin system. So the figure shows that schematic diagram and principle of this operation of the central system, or also we call it as bin system for the burning pulverized coal. So what happened here? The raw coal bunkers, the crushed raw coal are dried using hot air or flue gases fed into the pulverizer. So the pulverized coal from the pulverizing mill is passed to the cyclone separator. Okay, cyclone separator. You can see this. This is the cyclone separator. Once it is enter into the this all raw coal or crushed coal are enter into this cyclone separator. So what happened? It is separated by the cyclone separator, and it fed back to the mill. So once it is pulverized coal is then transferred from the separator to the central bunker, that is we call it as bin, through a conveyor system. The pressurized air from the forced draft fan supplies the stored coal to the burner. So this air not only carries the fuel, but also it acts as a primary of the fuel combustion for the combustion, and secondary is supplied to the burner separately to assist the complete combustion. So here we are providing two airs. One is primary air and secondary air, and this secondary air is assist complete combustion of the fuel. So next, will come to the advantages. It is highly flexible, and it is independent of the operation of the coal pulverization, and also it is less wear and tear, and it is handled very easy. The coal size can be also be controlled by efficient way. So this one can be controlled in a efficient way. And also disadvantage is that it is some quite somehow it is expensive, and it occupies more space. Okay, and requires complicated coal handling system, and power consumptions in of this is very high, and chance of fire hazards are more since pulverized fuel is stored. So that is one of the drawback, and operation maintenance costs also quite high. So this is all about the central system or bin system.